Section 8.2, testing a claim about a proportion. Remember, the best point estimate of P, the proportion of the population with a certain characteristic, is given by P hat, which is X over N, where X is the number of individuals in a sample with a specific characteristic, and N is our sample size. And it's approximately normal with a mean equal to P and a standard deviation equal to the square root of P times 1 minus P divided by N. If the following requirements are satisfied, there's 3 things there. Go ahead and give those a star. First one, the sample size, or the sample is a simple random sample. Second, the conditions for the binomial distribution are satisfied. And third, N times P and N times Q are both greater than or equal to 5. The test statistic is given by the formula listed there, however, not something that we really need to stress about since we are using the calculator. Give the box a star. This is testing hypothesis regarding a population proportion p-value approach with the graphing calculator. It works with both the 83 and the 84. Use the following steps provided that those 3 criteria are met that we just discussed. Step 1 is determine the null and the alternative hypotheses. The null is all the same, always equals to. And your alternative hypothesis depends on if it's a 2-tailed, left-tailed, or right-tailed test. Step 2, select your level of significance alpha that's given to you in the problem. Step 3, go to stat, go over to test, go down to, for me it was number 5, 1 prop z test, and enter in P naught, X, and N. And again, P naught is the value that's found in the null hypothesis, X is the number of successes, and N is our sample size. Then you are going to select one of the 3. It's either not equal to, less than, or greater than P naught. Highlight calculate, select enter, and then you're going to get 2 values that are going to be of importance to us. The first one is Z, which is our test statistic, and P, which is our p-value. If the p-value is less than alpha, we reject our null hypothesis, and then we state our conclusion. So we have a short example first. This isn't really what you would see on a test or on a quiz, but kind of gets us used to using the calculator. It says test the hypothesis using the p-value approach. Be sure to verify the requirements of the test. I'm going to go ahead and cross off that second sentence and go with the next one. It says assume that the testing criteria has been met. So first thing is you'd have to come up with your null and your alternative hypotheses after verifying that the test can be conducted. But they give those to us. We have P is equal to 0.6, and our alternative is going to be P is less than 0.6. So if you notice, we have N and we have X, and we also have our P naught value, which is equal to 0.6. And we need to go to 1 prop Z int and enter in all those values. You have to enter in P naught, X, and N. Make sure you select less than for your alternative hypotheses, and then you're going to select enter. And when you do that, you should get a p-value. And I got a p-value of 0, and we need to compare that to alpha. Alpha was given to us, and this is less than alpha. Alpha was 0.05, which means that we are going to reject our null hypothesis. I have my conclusion already typed in here for you guys, so take a second to write that down. It says there is sufficient evidence at the alpha equals 0.05 level of significance to conclude that we will have a proportion less than 0.6. I want you guys to realize what we're talking about here. To conclude that is what you need to be, it needs to match with what you have in your alternative.